Hi, welcome to HON. So now we are going to explore looking at a kinematics question. A particle P leaves a fixed point O and moves in a straight line so that t seconds after leaving O, its velocity v cm per second is given by v equals to t squared minus 14t plus 48. Calculate. These three we won't be doing. So calculate and show that the particle will not return to O. Okay, so this is a question thanks to Anglican High School, 2019 A-Level, A-Maths, O-Level paper, O-Level prelim paper. Okay, so what we want to do is we want to show that the particle will not return to O. And what is the best way to solve it? So give it 5 minutes and we will go through the answers afterwards. The hint is to consider the properties of this quadratic equation. Okay, now we are done looking at and studying this question. So let's try to solve this question. Show that the particle will not return to O. Okay, so let's understand this with a very, let's try to visualize this particle's movement. So the particle leaves a fixed point O, so this O, and it moves in a straight line. So let's say this is the particle, P, and it moves in this way, t squared minus 14t plus 48. Okay, so now let's actually analyze what does it mean to have a velocity of t squared minus 14t plus 48. So this is a velocity time graph, vt. Let's just draw a simple sketch. So let's see the roots of this equation. T squared minus 14t plus 48 equals to 0. So we can say that this is t minus 8, t minus 6 equals to 0, and t is 6 and 8. 6 or 8. So this is when the velocities are 0. Okay, so when the velocities are 0, t is equal to 6 or 8. So let's say this is 6, this is 8, and we have this graph over here. Okay, so by looking at this graph, we can see that here we have a positive value. So this is where all the particle moves in a positive direction. So let's just split this up. So this is when your particle moves in positive direction. And here is the negative, and here is positive again. So there's a reason why they ask this question, show the particle will not return to O. Because they want you to show that actually when it's moving in the positive direction, and this negative part where it moves backwards, so this is in the negative direction. So when you move backward, it doesn't move too much until the back of O. Okay, so we want to show that this particle will not return to O. And how do we do that? Actually, this we can just sort of find the displacement. The displacement of the particle and check that it never returns to O. Okay, so when we look at the displacement, we want to look at integral of v dt. And what is v? It's just t squared minus 14t plus 48. Let's find the indefinite integral first. So this is equals to t cubed over 3 minus 7t squared. So because this is t squared divided by 2 times 14. So it's 7t squared plus 48t plus c. Okay, so always remember to put a plus c over here because we have to determine what is c. So how to determine what is c? So one fixed point that we know is that this origin, the particle is at the origin at time equals 0. So when t equals 0, the s, the displacement is 0. And we can just substitute this inside the equation. But t is 0, 0, 0. So c must be equals to 0. So now we have proved that s is equals to t cubed over 3 minus 7t squared plus 48t. Okay? Now, we want to show that the particle will not return to O. How do we do this? We just need to show that this guy is always positive. Do you agree? Okay, so how do we show that this is always positive? So let's say, so we can actually just do a simple factorization over here. This t squared over 3 minus 7t plus 48. And take out 1/3. So I can multiply 3 on. So you just need to prove that this is larger than 0. So you just prove s larger than 0. So this guy, t times t squared over 3 minus 7t. So I'm just going to take out the 3 over here. So it's 1/3 t squared minus 21t plus 48 times 3, which is 144. We're going to prove that this is larger than 0. But how do we do that? So let's look at, so one thing we know is that t must be larger than 0. Okay, so we just need to prove this is larger than 0. So if t is larger than 0, let's just try to find if this is ever negative. Because we want to prove that this whole thing is larger than 0. But t is already larger than 0. So this guy must be larger than 0. So now we have reduced the problem to prove that t squared minus 21t plus 144 is larger than 0 for all t larger than 0. And how do we do this? One thing we can recall is the discriminant. So discriminant says that b squared minus 4ac must be smaller than 0. Okay, so this is so that there's no solution to this equation. Okay, so let's try this. B squared is 21 squared minus 4 times 144. And this is 441 minus 576, which is obviously smaller than 0. So now we have proved that the discriminant smaller than 0 means there's no solutions or no roots. Okay, no roots. And moreover, this is a U-shaped graph. T squared has a coefficient of 1. So this means it's a increasing, is a U-shaped graph. Okay, and this is always above the x-axis or t-axis. And therefore, since there's no solution and a is larger than 0, d smaller than 0, then we have t squared minus 21t plus 144 is larger than 0. Okay, so now, since we have proved that this is always positive, this whole thing is therefore always positive. And if this is always positive, that means the particle will always have positive displacement. And this shows that the particle will not return to O. And therefore, we have proved the statement. So, ending speech.
Yo! I hope you find this video helpful. If you do, give us a thumbs up and subscribe to our channel. we have prepared something for you because me and him, we really like you. And we want to give you the best. That's why we have created this free cheat sheet for you. Exclusive cheat sheet. And you can join our free community where any question you can feel free to post inside the community. Me and Zhen Hao will be more than happy to help you. So yes, before you go, remember to download the cheat sheet and we will see you very soon. Peace. Don't get blank.